AP Chemistry, Unit 6.2, Energy Diagrams. So we have an example here of an endothermic and an exothermic energy diagram where we can see the initial potential energies of our reactants, followed by our hill that we have to overcome, which will be representative of our activation energy, to the overall energy of the transition state, and then we will fall to the overall energy of our products in both. The main differential between your endothermic and exothermic reactions is going to be where your energy from your reactants to your products ends up being. So if your energy of your products is higher than your energy of your reactants, then you are going to be endothermic overall. You had to absorb energy in order to make this reaction occur, and your products have a greater amount of energy than you started with. Whereas if your energy of your products is in a lower position than your initial energy of your reactants, then you are going to be exothermic. Okay, you lost energy to the surroundings. You have a negative delta H, and so you will have given away any extra energy, and so you are exothermic. The overall change in energy that accompanies physical or chemical processes can be described by the energy diagrams that we just saw above. The difference between the energy of the products and those of the reactants gives the overall change in energy of the reaction and determines if we are going to be endothermic or exothermic. Again, endothermic processes have reactants with a lower energy than that of their products, and exothermic processes have reactants with a higher energy than that of their products. Activation energy is going to be used to break intramolecular forces and or intermolecular forces. And the energy released from the reaction comes from forming new bonds and or new attractions, and is going to determine if the reaction is endothermic or exothermic, depending again on just how much energy is released from the transition state to the state of our products. If we don't release quite as much energy from where we started, then we will be endothermic, whereas we release a lot of energy from our transition state down to our products, we will be exothermic. Catalysts are added to reactions in order to increase the overall reaction rate. They are not consumed in the reaction, but they do provide alternate pathways that overall lower the activation energy. Another very important thing to note is that your overall enthalpy, your change in H or delta H, is not going to be changed by a catalyst. So you won't change the reaction from being endothermic to exothermic or the reverse. That's not going to happen with an addition of a catalyst. The only thing a catalyst is going to do is lower the overall initial hill that you have to climb in order to get to your products. So we will lower this hill, but we will not change the initial and final energy representations of our reactants and products. Very, very important thing to note there.